Recording. So welcome everyone to our next webinar. This webinar is the second in the series of prospect mapping from interpretation to volumes. As some of you might have joined a webinar about a month ago that Maslina ran from our Kuala Lumpur office about time structure maps. Today we're going to talk about depth maps. So the time depth conversion. My name is Karolina Harvey. I'm a training and support geoscientist at Petrosys in our Glasgow office, and I'll be running a demonstration for you today. Just a couple of technical announcements to start with. First of all, everyone is muted. This is by default, and this is on purpose to ensure the best audio quality, so there's no background noise. Also, this webinar is being recorded, and the recording will be available in a couple of days on our website. If any one of you would like to get hold of my PowerPoint, let me know. And also, if you have any questions, please type them into the questions box, and I will monitor this and I will answer those questions after the webinar. Okay, so let's start. The agenda for today will start from a short introduction. I've got maybe 4 slides to show you, in which I would like to talk about why would you use Petrosys for depth conversion, about our data integration that we offer, and the depth conversion templates in Petrosys, and also about workflow management. After this, we will move on to live demonstration, and after the demonstration, there will be time for questions. So why would you use Petrosys for depth conversion? First of all, it integrates data from a variety of sources. So you will usually have your interpretation data, your seismic interpretation, for example, in the interpretation package, such as Petrel, Paradigm, Kingdom, OpenWorks, or any other package. Your wells may be also sitting in a well depository database, such as OpenWorks database, and stacking velocities often sit in a text file. They come in the segue formats. All of those formats and all of those different data types and different data sources we can connect to, and we can run seamless depth conversion in Petrosys using data from a variety of those sources. Petrosys also has functionality to model depth in a variety of situations. So depending on how many data you have available to you, we can adapt and we can run depth conversion nonetheless. So for example, if you have no velocities, we can run depth conversion with no wells or no seismic. If you have a very low number of wells, we can also adapt and we can create some workflows for depth conversion with this. If you have larger number of wells and also 2A time and stacking velocities available, there will be more sophisticated methods that you can use than in Petrosys, such as kriging and kriging external drift, which exploit your information from your data farther and give you some extra details and extra information about your data. Petrosys depth conversion is fast and accurate. And you can use it solely in Petrosys. However, if you would like to use depth conversion, you're using anyway depth conversion in your interpretation package, Petrosys can constitute an excellent QC tool for you when you're building a full geological model. In Petrosys, you don't have to build a model. The task creation is fast, but the depth conversion is very reliable. Therefore, when you're using Petrosys in connection with your own interpretation package, you can QC and you can cross-check if your model is built correctly. And we also offer easy-to-manage repeatable workflows, which a lot of our users like and use a lot. This means that we can incorporate a workflow, depth conversion task into a larger workflow, make it automated, and as much automated as you wish you can make it. And also these workflows are savable, they are repeatable, so then you can use it for more data for other projects. You can share it with your colleagues as well across the company. So this is a short example, a small example of an integration of data. And I just would like to stress that this is just an example. So I picked some interpretation packages. Your data can be in another package. Maybe I haven't mentioned it here, but Petrosys connects to most of the interpretation packages available on the market. So let's say your wells will be in Kingdom and in OpenWorks, or in OpenWorks. Your seismic interpretation will be in Petrel and in DAC Insight. And your stacking velocities will be in text files or segues. Petrosys can connect to all of those sources and can use simultaneously all of this data for a one depth conversion workflow, and this can happen at the same time without creating any copies, and so you can run depth conversion using data from a variety of sources. And as an output, we produce presentation quality, company standard, beautiful depth maps, which can be also produced in a sequence for different tops, for example. We also offer depth conversion templates. So if you go to surface modeling, grid processes arithmetic, you'll find templates, and then there is a template group there for depth conversion. So if you look through this template, you can choose one of those templates available, such as using average velocity or interval velocity, or you can choose one of the more complex ones, such as midpoint constant V0 or V0 K. So all of these are available to you. However, if you're already doing your depth conversion and you're checking the relationship between the time and depth in another package, for example, using Petrel, and you use Excel, you use Excel to derive your own equation, your polynomial, you can just copy this polynomial into Petrosys, into the formula window, and you can use it for depth conversion in Petrosys. This template then can be saved into the templates, your own templates, and it can be shared with your colleagues, or it can be reused. And the task that you're running can also be saved, and it can be reused for more two-way time grids, for example, or for other data, or just for different projects as well. So as we are at the tasks and the workflow management here, Workflow Manager allows you to incorporate depth conversion task into a larger workflow. So you can make this workflow automated. You can, for example, make an output of one task to flow seamlessly as an input to the next task. You can also loop over multiple grids, two-way time grids, for example. So here on this in this example of a workflow, I'm creating two-way time grids. I'm creating them for different tops. Also, I'm depth converting those grids, then tying them to the well tops, and I'm also going to run volumetrics in the end, so volumetric computation, and send the ready output depth grids to Petrel. So depth conversion is here as part of a larger workflow. Creating groups helps you also manage tasks activity, and it makes the workflow look more tidy. So if you're saving it, sharing with someone else, or if you're archiving it as well, whoever later on will open this workflow, they will know exactly what this workflow does and what each stage of this workflow does, which task does what. So it will be easy for others to understand and continue or to reuse this workflow. You can also group tasks in one depth conversion group and use different depth conversion methods. Run this group against one two-way time grid, for example, and check which depth conversion method works best for your data. Or you can just incorporate this into top groups here and run it against different tops. And this is all from the introduction, so let's move on to the live demo. And I'm starting from a map that actually Mazlina created a month ago, as some of you will remember it already. So Mazlina took two-way time data from Petrel, and she created a time map, time grid here. And she displayed it on a Petrosys map, and she also finished this map with beautiful finishing touches, such as a title block, color bar, and location maps, and so on. So on this map, Mazlina also created from a workflow fault polygons from fault stacks, and I overlaid on this map those polygons over the grid. So if I switch them off now, you see that the grid actually also has fault polygons embedded within it. And Mazlina also gridded within those fault polygons. And why she did this? She did this for further purposes of our whole workflow that we are going to run over those few webinars. So for me, for depth conversion, but further on for volumetrics, this is very important to grid within faults so that you don't lose any volume underneath the fault planes. And as we are actually at it, I would like to show you here to draw your attention to Petrosys gridding algorithms, which deal very well with faulted data and with faulted surfaces. So here, the Petrosys is creating beautiful surfaces within fold polygons, which run parallel to the contours run parallel to the fold edges, and this creates beautiful and geologically realistic surface. And this surface now I'm going to take to surface modeling, and I'm going to depth convert it. So I'm using also task that Maslina used last month. And this is a task that she used. So she took data from Petrel, 2A time data for top tarbet formation. And she also used fold stacks from Petrel, and she created fold polygons here. And first of all, I'm going to rename this task. So do a little bit of a workflow management here. So I'm going to call it something to make it easy for me to understand. So grid 2A time top tarbet. Okay. And I'm going to create a group here as well. Time structure. And now I can add on my own tasks here for depth conversion, and further on I'm going to tidy them as well. So to do depth conversion in Petrosys, you can go to Grid Processes Arithmetic. Clear this formula window here, go to Insert and search for a template group called Depth Conversion. So Petrosys can operate different processes on grids, and you can use different template group here, for example, just simple mathematical functions or geoscience examples and many others. And there's also depth conversion group here. And you can use one of those depth conversion templates, so say using average velocity, which is the simplest you can find, and then this populates the formula window here, and you can use this template and just map to your 2A time grid, to your velocity grid, and create a depth output grid. If you would like to use your own template, you can delete this formula here and type in your own formula in this formula box. So for example, copy one from Excel, paste it over here and use it for your own data. And this way you can depth convert in Petrosys as well. But what I want to show you today is actually one of the newest options in Petrosys for depth conversion, and it's sitting under the velocities menu. Well-timed depth trend conversion. So I'm just going to select this task here. So first of all, in this task, I need to choose my input grid that I want to depth convert. So this is my top tarbet grid that is displayed here on the background on the map. And I'm also going to use well data. And here I can choose data from a variety of sources. So probably, these are quite a lot of sources here. So I'm sure you will find one of the sources that your data sits in. If you can't find it over here, let us know and we will see how we can bring it into Petrosys so you can do depth conversion in Petrosys as well using your data wherever it sits. Today I'm going to use Petrel. I'm just connecting to my Petrel project. And this populates this window here below with wells available in Petrel, which have the top that I selected here, so top tarbet. And these are my wells listed. So I have well name, UWI, 2A time, TVDSS, and Petrosys creates automatically pseudo velocity. So it calculates pseudo velocity here. It does the same in our own WDF, so well data file. And I've got easting, northing, and I've got a few empty columns over here. And why they are empty, I'm just going to explain in a minute. But first of all, what I want to do before I run a depth conversion is check the relationship between my 2A time and depth data in the wells. So when I right mouse button click anywhere here in the white field, I can select Analyze Data in Chart. This opens a new window here where I can cross-plot my data on this cross-plot here. So my X values are 2A time. I can obviously choose any other value if I want to cross-plot any other data and check relationship here. The 2A time values are growing here with the X-axis. The next thing is depth values. They are growing downwards here, so a little bit different. I can invert it as well, but I'm just going to leave it as is. And I can also choose to use third variable here, and this can be, for example, delta TVDSS, which is I can calculate later, or at the moment I'm just going to use my depth values from the wells just to make it more emphasized where these values are growing and where they are small. So on the color gradient, you can see that the values are growing with towards the red colors here. Petrosys automatically created a line of best fit through this data here. And the equation is shown over here as well on the graph. What you can do is go to line of best fit, click on this tab here, and change this line of best fit here from linear to polynomial, exponential, power, or logarithmics. So I'm just going to choose polynomial here, for example, and I found that this fits through my data better. Petrosys automatically recalculates this line of best fit, and the equation is also reported over here. And this graph, once I am happy with it, I can export to PDF format, or I can export it to PowerPoint. So with just one click, when I click on it, it shows into my PowerPoint on my previous slide. So that's you can use it as well for presentations. The next thing is that I can also monitor this data. So I can click on a well here on the graph, and it highlights on the background here. So I know which well it is, and I can QC this well. I can check what are the values for this well. If I see that there is something wrong with the values, if this well is too much of an outlier, for example, it would be somewhere here on the graph. My wells are quite good here, so I don't need to exclude any, but I can right mouse button click and exclude selected point. Petrosys automatically recalculates the line of best fit through the remaining points. It excludes it here from the list as well, so it's not going to be taken into our calculation of depth. And I can also re-include this point and change the line of best fit. Okay. So let's close this window for a moment, and now let's go back to those empty columns here. Why they are empty? So they allow us to run cross-validation on this data. And cross-validation, if I tick on this box over here, it will start running. And this is a technique that allows us to find any outliers in our data, any anomalous data here. So first of all, what it did is it gridded my all depth values from well, and this is the value. These are the values when they are gridded. The next column shows me the difference between those gridded values and the actual values in the well. And then each of those points that I'm using here is removed one by one. So first, the first point is removed, the grid is ran without this point, and then the value from this location of this point is back interpolated to this point location, so that we know what value would there have been if this point had been missing. So this is the estimation basically of the value of the grid with this point missing. And the next column shows you the difference between the estimated value and actual value in the well. And this is actually the most important information here, because when I sort it now by the values, the growing values, you will see that the highest value is here for A16 well, and it's 30 meters, and maybe it's not that much comparing to about 2,000 meters depth. However, it's quite more than any other of those wells, so this well is definitely outlier here. What I can do now is to go back to my interpretation package and check this well and see why this well has such a difference. And there may be several reasons. For example, a well can lie at the edges of the grid, away from well control, and the gridding algorithm could have extrapolated towards this well. So that's why we have such a large value here. It can be lying on a fault block, for example, or there just may be a erroneous spec in the well. So what is important is that it flags up this well, and we can go and QC this well. Okay, so now when I'm happy with all my wells, I'm just going to include it because there's not such a massive difference here. I'm just going to change that again to polynomial, so use my line of best fit equation. And the last thing in this window here allows me to create linked depth conversion arithmetic task. So if I tick on this box, I can select my 2A time grid again and just give a name to my output depth grid here. And this will automatically open a task when I click on OK here, which is our grid processes arithmetic task. So I don't need to go in here and type in my own equation. Petrosys copies this equation from the previous task. It also fills all my constants here, so all my parameters, the output grid name and the input grid. And all I need to do is maybe switch on faults, which I want to use obviously for my depth converted grid as well, and run this task. So before I run it, let me just tidy this again here, this workflow. So rename this task. And this one as well. I'll call it grid arithmetic. Okay, and I'm going to create a group here called depth conversion. So now whoever is going to continue, and this is going to be Peter next week, he can just take my task and continue creating thickness maps here up to volumetrics as well. So now once I have this group, I can run this group. So run my depth conversion and display my grid on the map. And I'm just going to switch the time grid off, display my top tarbet depth wells grid. And check also the color gradient. It should be inverted now so that the red values are in the most shallow parts of my grid. And this is now correct. You can see again that I've used faults and the fault planes are gridded nicely, so it's going to be good for volumetrics. And the last thing I want to do is to display color bar here for top tarbet depth. Click OK and move this color bar where Masdina kept her 2A time color bar here as well. And this is pretty much all. So let me just tidy this up as well. Create a group here, depth map, and put the faults on top of this group. Sorry, once again. Move. Doesn't seem to be that easy. I always find it hard at the top. Never mind. I'm just going to move it on top of this grid to make it easier. So now I overlaid my fault polygons here as well, and I can now print this map, export it to raster format, for example, and use it in presentations. And this is all I wanted to show you today. So let me go back to the PowerPoint quickly. There are some more existing videos that are showing other methods of depth conversion in Petrosys on our website. So go to our website, please go to videos, video library, and select depth conversion with Petrosys, for example. This is an old video, which is still very relevant and correct. And it will show you how to do depth conversion using kriging and kriging with external drift. This video over here shows you the opposite situation. When you have not much data, you don't have well velocities. How are you going to do depth conversion without velocities? And there are also some supporting videos that you can find useful when you're doing depth conversion. For example, gridding with stacking velocities, how to grid stacking velocities so you can use them later on for depth conversion. You may also find useful our how-to documents that are available on the client portal, and these include also depth conversion workflow guides. So if you go to our client portal, go to the Learn section, and then search, so Control F, search for depth conversion, and you should find at least 4 documents here. If we will be doing more documents, creating more documents, we will definitely be uploading them to the website. If you have any questions and you would like to know how to do depth conversion with the data you have, let us know, get in touch with us in support, and we will be very happy to help you. And if you would like to see further prospect mapping, how to do thickness maps, how to calculate volumes, please go to our website and to support and webinars and register for the next webinar, which is on the 16th of November, and the next one on the 14th of December. And today, thank you very much for your attention. I'm going to stay on and listen to some questions here. So if you have any questions, just type them into the question box and I will try to answer them right now. Thank you very much.